Okay, as we continue our discussion of the derivative and ways of finding the derivative, we want to find a shorter way. The limit definition works great, but it can be quite tedious sometimes to go through all the algebra to do that. And so we need some shortcuts. And so the next few sections here that we're looking at are going to be shortcuts or faster ways to find derivatives without working out the whole limit. The limit definition, the limit of will always work, but this is we want to be able to find derivatives fairly quickly, and so we're looking at faster ways to do that. And kind of the most basic rule is the power rule, which says that if you have f of x is equal to x to some power, then you find the derivative by bringing that exponent down, multiplying by that exponent, and then subtracting 1 from the exponent. So if you've got a function f of x equals x to the 7th, then f prime, the derivative of that, we're going to multiply by 7, and then we're going to bring the 7 down, the exponent down, and then lower the exponent by 1. So I get 7x to the 6th. If you've got f of x is equal to x cubed, then f prime of x would be 3 times x squared. We're going to multiply by the exponent, lower the exponent by 1. And this works even if you don't have integer exponents. If you've got f of x is equal to x to the negative 5, then f prime of x would equal negative 5 times x to the negative 5 minus 1. We'd have to be a little careful there that when you're subtracting from your exponent, negative 5 subtract 1 more becomes negative 6. It's not negative 4, it's negative 6 when you subtract 1, right? And so we can use that anytime you've got any sort of power, you can do that. It even works with the square root function. I think that we learned in algebra that you can write the square root as the 1/2 power. Square root is equivalent to the 1/2 power, so that when you take the derivative, you're going to get 1/2 x to the 1/2 take away 1, which would give you 1/2 x to the minus 1/2 power when you take the derivative of something with a square root. And so, sometimes we'll have things in this square root form where we can write it as x to a power, and then once we can do that, we can take the derivative. And if you've got something like 1 over x to the 5th, well, our properties of exponents allow us to rewrite that as x to the minus 5, and then we can apply the power rule to that, multiply by the exponent, and then subtract 1 from your exponent, so we get minus 5x to the minus 5th. All right, so product rule is pretty straightforward. If we want the constant rule, it says that if f of x is equal to a times g of x, then f prime of x would be a times g prime of x. So if you've got a constant in there, if you've got f of x equals 4x cubed, what you do when you take the derivative is that the 4 multiplying out front just sort of carries through. 4 times 3x squared. So I get 12x squared as the derivative there. We just use the 4 carries through, and you use the power rule, bring the exponent down and lower the power by 1. So I'm going to get 3 times x squared for the derivative of x cubed, and the 4 just carries along there. If you've got f of x is equal to 8x to the 7th, f prime of x would be 8 times 7x to the 6th. And then, of course, you can simplify that. 7 times 8, I shouldn't do that one. That's the one that always gives me problems. I'm pretty sure it's 56, right? Yeah, it's 56. Okay. So 56x to the 6th would be the derivative there, in there. F of x equals 11 over x cubed. We'll have to rewrite that as 11x to the negative 3 power. And then I can apply the power rule. I can multiply by the exponent. 11 times negative 3, and then subtract 1 from your exponent. So negative 3 subtract 1 more gives you negative 4. So it's negative 33 x to the negative 4. If you want to, you can also write it as negative 33 over x to the 4. You can move that x to the minus 4 down to the bottom. But I believe most software will recognize negative 33x to the minus 4 as the answer. You don't have to rewrite it as negative 33 over x to the minus 4. A lot of times that'll get recognized as the correct answer in there. So if you got a constant out there, you just multiply it across. And if you even have just a constant, they sometimes talk about that. If you just have like f of x equals 8, there's no 8, there's no constant in there. What we can do is we can think of that as, I'm going to change my color here a little bit here. You can think of it as there's sort of an implied x to the 0 power there, right? You know, when you've got that constant term, there's no x involved. You can think of that as being multiplied by x to the 0. X to the 0 is 1. And so when you take the derivative, you'll have 8 times 0, x to the negative 1 power. But anything times 0 is still 0, so this is just going to give you 0. So if you've got a constant being multiplied by x, that carries along. But if you've got just a constant, if it's just a number, if there's no x involved, then its derivative is 0 as well. And, you know, we can kind of do something similar that if you've got, let's go back to black here. If you've got f of x is equal to 11x, then f prime of x would be 11 times 1x to the 0, because this is x to the first power. So we're going to multiply by 1 and then lower the power by 1. But x to the 0 is just 1, right? Anything to the 0 power is pretty much 1. There is a little bit of an exception to that, but I don't want to go into that right now. And that should give us, so it's just 11. So the derivative of 11x would just be 11. That if you've got x to the first power, when you take the derivative, you just get left with the 11 there. All right. And then the product and sum rule says that if you're taking the derivative of g of x plus h of x, if you've got a couple terms added together and you need to take the derivative, you just do piece by piece. So I'm just going to do g prime of x times 8 plus h prime of x. Or if it's minus in there, it carries down as a negative. No, not the product and sum. Difference. Sum and difference rule. That is the total wrong thing to say here. It's the sum and difference rule. There is a product rule. Sum and difference rule. That we're going to talk about here in a day or two, but sum and difference rule is pretty nice. So if you've got a function that is, 3x squared plus 4x plus 11, and you need to find the derivative of it, you just go term by term. The derivative of 3x squared, I'm going to multiply by the exponent, lower the power by 1, so it's going to be 3x to the first power. Derivative of 4x would be 4 times x to the 4 times 1, right? That's x to the first power. So that's going to be 4 times 1x to the 0 power, but x to the 0 power is just 1. And the derivative of 11, if it's a constant like that, its derivative turns out to be 0. So our derivative would just be 6x plus 4. If you've got f of x equals 8x cubed minus 4x squared plus 2x minus 3, then the derivative, we're just going to go turn by turn. 8 times 3, 3 times 8 is 24. Lower the power by 1. If it's subtraction, it just stays subtraction. 4 times 2 is 8. Lower the power by 1, you're going to get x to the first power. The derivative of 2x would just be the 2, because it's the x to the first power. When you take the derivative, the x goes away. And the derivative of, you get x to the 0 power, which is just 1, so we can ignore that. We don't have to write that down. And the derivative of the negative 3, because there's no x there, its derivative would be 0 in there. So sum and difference rule are just, do term by term, kind of combine the product, the power rule with what you have before in there. All right.